What transformations must be applied to map f of x to g of x? Graph both functions. So your f of x is the square root of x. G of x is negative of the square root of 1/4 x. Now this negative sign out here, I know that's a vertical reflection. And sometimes we call it the x-axis reflection because it's reflected over the x-axis. So really that's more precise than just a vertical reflection. Now this 1/4 in here, with the input variable x, that is going to be a horizontal stretch or shrink. And since we have 1/4, it's going to be a horizontal stretch by 4. Okay, now let's take a look at the graphing calculator and we'll graph those functions. Okay, I'm going to use the square root x that's already in there. Then it's negative, and then open parentheses, 1/4, and then times x, just like that. Square root, and then open parentheses 1 divided by 4, and then x. Just like that. That's negative square root of 1/4 x. Let's look at the graph. There's square root x right there. And right down here, this is our negative square root of 1/4 x. So there's definitely a reflection through the x-axis. Then notice how the function really doesn't go down as far. It's not a complete reflection where the g of x is closer to the x-axis. So let's look at the table, see if we can get a pattern. Okay, so we have 0, 0, and then 1, negative 0.5, then 2, negative 1. Let's scroll down a little bit more. Okay, so notice from 0 to 1 is a distance of 1 on the inputs. Then from 0 to negative 1 is a distance of 4. So that's 4 times the horizontal stretch. I want you to notice that for f of x, from 0 for an output to 2 for an output, it's a distance of 4 on the inputs. It goes from 0 to 4. So if we have 4 times the stretch, it should be that we have an output of negative 2, including the reflection, at x equals 16. So let's scroll down to 16 and see what we have. Okay, right there. 16 for an input gives negative 2 for an output. So it's negative 2 because of the x-axis reflection. So I hope using this table is helpful for you in understanding the horizontal stretch. You can't really quantify that stretch using the graph. You can see that it's stretched horizontally, but you can't tell how far. So that's why I use the table to look at the inputs and outputs to make sure it's by 4, which is what I originally predicted. So here are the transformations. We have x-axis reflection and horizontal stretch by 4.